Hello everyone, welcome back to the Homework Helper. Today we're going to be taking a look at Lesson 1 from Unit 7. Let's dive right into the ready question number 2 and 3. So here, this one's asking us for the circumference and radius of each circle. And keep in mind the equations for circumference and area are highlighted there in red. So for number 2, this actually is pretty... I think it's pretty straightforward. So the area is going to be pi times r squared. So 8 squared is 64. So we get 64 pi. And make sure you add the units. It's in square inches here. So if we're dealing with area, it's inches squared. If we're dealing with circumference, it's just inches. So this is 2 times 8, or 16 pi. And now we're dealing in inches. Number 3 involves us filling out a table, and 4 asks us to identify some patterns that we might find from the table. Let's start across with the area. We'll start with this small circle here, so that's going to be 1 squared times pi, and I'll just write 1 pi meters squared. We'll do the circumference of that small circle. It's 2 times 1, or 2 pi meters. The second circle is 4 pi meters squared, and their circumference is 4 pi meters. So 3 is 9, and then 6. 4 would be 16 pi meters squared, and 8 pi meters. And then 25 pi meters squared, and this would be 10 pi meters. All right, so number 4 asks us to identify any patterns that we see. We could start with some obvious one. There's a lot of things you could put here. I'm just going to put a handful. All right, so all answers have pi in them, or in terms of pi. Area is meters squared. Circumference is in just meters. Let's see here. The growth, further circumference. Right, we've done this in the past, so that goes up by 2, that's up by 2, that's up by 2. So we'll say that for circumference, we have constant, we'll say growth. All right, and because it's constant, that means it is going to be linear. All right, we got a linear growth there. Area, it's not constant, so see we go from 1 to 4. 4 to 9, right? So this area is not linear. All right, there's a bunch of other things that you could put here. So you can even be, like, as long as it's not wrong, you could say it. So like you could say if you look at the 2 meter circle with a radius of 2 meters, they both are 4 pi, but one's m squared and one's just m. So, right, like I said, lots of things you could say. I just wrote down some of the more noticeable things, or what I think would be the most relevant things. But yeah, lots you could say there. All right, now let's progress on to number 5. Here we're talking about marking at least 4 possible centers of rotation that would work for rotating the image to the pre-image point. All right, so that seems like kind of a lot that's just being said there, but this will come up again and again and again with these types of problems. All these centers for rotation points, they're going to lie on what's called the perpendicular bisector of a segment that connects the image and the pre-image. So if I were to make a segment here connecting A and A prime, right? I know that all of the points for the centers of rotation are going to fall on the perpendicular bisector here. And I don't need to really construct it for this one because it's just a vertical line. And I'm actually not going to be constructing any of these, but you can, and it'll give you a more exact outcome. So all of these points here that I'm making in red, all of these points are potential answers here. So that's what? 9, we could say 9, 0, 9, negative 1. We'll say 9, negative 4. I mean, they're like literally all of these points are fine. Let's see here, 9, 1, 9, 2. There's a lot. So anything that falls on that vertical line would be okay, right? And it just say all the points. So that line right here, all points on line x equals 9. Number 6 is similar, right? We got our segment connecting A and A prime. Our perpendicular bisector is going to be a line that passes through. It goes through right there. Looks something like this. I'm just going to so all of these points right here on this line are going to be okay. So we got, let's start with 5, 4 is good. 6, 5 is okay. 5, 4, 3 and 3, 2. Right here we can come up with an equation of a line here. We got the slope here is positive 1, and the y-intercept here is at negative 1. So it's going to be y equals mx 1x plus b. So this is all points on this line. See here. Let's go to number 7. Let's see, 1, 2, 3, 4. So we started 2, 3, 4. That's right. 5, 6. Let's go to number 7. Same deal. All right, here we have this line. It's going to go through a point right here. All right, I'm not going to like fill out all of the points here because I'm just going to sketch this in. So the slope here is 1 up 2 to the right, 1, 2, 3, 4. So P to P prime has a slope of positive 1/2. Right, so the perpendicular bisector is going to have a slope negative 2. Okay, so I'm not going to list out all the points, although we can, and maybe I will. So it's going to look something like this. All right, it's going to have a slope of negative 2. And I know it's going to go through this point right here, and that point is negative 4, 5. So it goes through this point. It has a slope of negative 2. Right? So I'm going to plug this point in using point slope and get my equation. So I get y minus 5 equals negative 2 x plus 4 but this would be plus 5. So this should be not 4, 5. I was just going to say this is negative 4, 4. Apologies. And this would be plus 4. I get the wrong point there. So it's negative 4, positive 4 at this point. Sorry about that. All right, so this gives us y equals negative 2x minus 4. So any point that falls on this line is going to be good. So we can go ahead and plug in any value we want for x. Let's try x is equal to, say, negative 5. Plug in negative 5, we get positive 6. So we get 5, 6 would work. If we plug in x is, say, 0, we get negative 4. We plug in, and we already have this point. Let's plug in x is equal to negative 2. We get 0, so we get negative 2, 0. All right, so those 4 points are good to go for this, but basically anything that's on this line is going to work out. All right, let's progress to number 8. Complete the sentence. The center of rotation will always be located on the perpendicular bisector. And I've kind of been saying this about all of these ones that we've done, or at least numbers, 5, 6, and 7. So they always fall in that perpendicular bisector. You can find an equation of a line, and all the points that fall on that line are going to be okay for centers of rotation. So that takes us through number 8. We got 11 and 14 left. Let's jump down to 11. We get the center of rotation. There's lots of things that we can do here. We're going to find a lot of, there's a lot of things that we need to do here. We basically want to make lines. And I actually don't even have a construction tool that I can use on here. But we're going to connect all of our images and after images. So we got these 3 lines here that I'm adding in. And basically this center of rotation is going to be where the 3 different perpendicular bisectors intersect. So I'm just going to sketch it in. Hopefully it's not too bad. So the first perpendicular bisector, let's take a look at, let's take it A and A prime. That's going to go, it's going to be a vertical line at negative 1. So there's the first one right there. All right, well that should give us a pretty good indicator as to what the x-coordinate is going to be. Because this one only has negative 1 for it, so it's going to be an intersection somewhere on negative 1. Right, so this one is the perpendicular bisector of A and A prime or A apostrophe, whatever you want to call it. Let's do the same thing, except for this one is for C and C prime. And this one's going to actually look, it's going to go something like that. All right, that's the perpendicular bisector for C and C prime. And then we got one more for B and B prime. And let's go with, we'll just do black for that. And this one's going to be, it's obviously going to connect here. looks something like that. Okay, so you should be constructing these to get a more exact value. We do know that the center rotation for these is going to be somewhere around -1, and it looks to be somewhere around -3-ish. The actual answer is -3.25. But if you construct that, you can see all we're doing is taking the 3 perpendicular bisectors and figuring out where they intersect. Okay, so shouldn't it's not anything that much different than what we did for the previous problems, except for we're doing the perpendicular bisector 3 times and finding out where that point is. All right, one more problem on this assignment, I believe, is number 14. And this is kind of a throwback problem. There are 2 similar figures, pre-image and image, indicate whether the scale factor should be greater than 1 or less than 1. And these ones are kind of just like a recall. Right, what happens? So what happens to this image right here to get this one? Is k less than 1? Is k? So meaning is k a fraction? It is. And it looks to be, this distance here is, was that 2? And this distance here is 1. So the scale's back a half. So k is less than 1. And that's because the image gets smaller. All right, so that will take us through lesson 1 for unit 7. Hopefully this was helpful for you. A couple of tricks to pick up along the way. All right, I will see you on lesson 7.2 or lesson 2 for unit 7. Hopefully this was helpful for you. Thanks for watching. Have a